Hi guys, welcome back to 11.6. Today we're talking about estimating population size. If you remember from yesterday, we talked about what a population is. Population is the total number of people that you are interested in when conducting a survey. So if you're curious about students' opinions on sports, your population is a school, it's your students. If you're talking about lions in the wild, your population is the amount of lions. It's the total number of any individual or species that you're curious about. But sometimes we don't know what the population size is. So example, if we're talking about lions in the wild, we might not actually know how many lions there are. So we don't know what our population size is. We don't know what that total number is. But what if we were able to take a sample size? So maybe the amount of lions in one town in a particular country in Africa, and we're able to make a generalization of if there are this many lions here, well, how many lions must there be everywhere? So we were talking about estimating population size based off of a small sample. How common are these particular individuals or species in any given place compared to how many there might be total? So let's look at our first example. Researchers tagged 100 fish in a pond and then released them back into the pond. So again, we're talking about fish in a pond. That is our species that we're considering. Later, they captured 60 fish and found that out of the 60 that they had caught, 3 of them were tagged. Estimate the number of fish in the pond. So they're saying researchers tagged 100 fish. So in the morning they went out, they caught 100 fish, and they put 100 tags on these fish, released them back into the wild. Then later that day they went and caught 60 fish. However, out of the 60 fish they caught, only 3 of them had been caught earlier that morning and had tags on them. So based off of this information, what can we imagine to be the total number of fish in this pond? So step 1, to be able to use the amount of tagged fish and then the recaptured fish to come up with a sample size. Step 1, write a proportion of tagged fish to total fish. So we're going to bring in the handy dandy whiteboard, ignoring that. And I've just copied down what they've said. And this is going to be the same model we use for all of our problems. Tagged fish in the pond over total fish. So the amount that they initially tagged over the total, and this is like grand total of all fish in the pond, set it equal to the tagged sample. So when they came back and pulled out a second amount of fish and only 3 of them out of the 60 were tagged, that's our sample size. That's we at random pulled out more fish, only 3 were tagged. So tagged sample over total sample. So in this particular instance, we're going to fill it in. The researchers tagged 100 fish in a pond. So how many did they tag initially? They initially tagged 100 fish over our total fish in the pond. Well, that's what we're told to find. Estimate the number of fish in the pond. So we don't know. That's our unknown value. So we're going to make that x. And now we set it equal to the tagged sample over the tagged total. Later that day, they captured 60 fish and found that 3 of them were tagged. So what are the number of tagged fish? The number of tagged fish were 3. Out of how many? What was the total of their second catch? The total was 60. So 3 were tagged out of 60. Step 2, write your cross products. Boom. And boom. So we have 100 times 60 is equal to 3 times x. 100 times 60 is 6,000. So 6,000 is equal to 3x. We want to get x by itself, so we're going to have to divide out our 3 to be able to isolate our x. Our 3 cancels out. What is 6,000 divided by 3? 6,000 divided by 3 is 2,000. So 2,000 equals x. That means we can assume while they originally caught 100 fish and tagged them, the total of fish in this particular pond is around 2,000. So there are about 2,000 fish in the pond. All right, I'm gonna move my reteach over and just use this, and we will work through them together. There we go. All right, complete to estimate the number of deer in the woods. So question 1, researchers tagged 80 deer. They later capture 15 deer and find that 5 were tagged. Estimate the number of deer in the woods. And then they give us part of the problem filled in. So they give us, I'm going to put this at a little bit of an angle. Number 1, they have 80 over n is equal to a blank over a blank. And we need to fill in those blanks. And remember what I said at the beginning, that this little formula is what we'll be using the whole time. The tagged of the initial over the total at the beginning said equal to the sample from the second time they look at the species or animal. So let's read it one more time and look at it again. 1 year, researchers tagged 80 deers. So how many did they tag originally? They tagged 80. They later captured 15 deer and found that 5 were tagged. They later captured 15 deer and found that 5 of them were tagged. So how many were tagged? 5 out of how many that they captured? 15. And now we'll do cross products to solve. 80 times 15, n times 5. N times 5 is 5n. Then we have 80 times 15. 80 times 15 is equal to 1,200. And then we'll set that equal to our 5n. We need to divide to get n by itself because we want to know what that total number of deer is thought to be. So we're going to divide both sides by 5. Our 5's cancel out on the left. 1,200 divided by 5 is equal to 240. So the number of deer in the wild is thought to be 240. So back on our sheet, we'll just fill it in. We had 5 out of 15. Then we did 80 times 15, or not, yeah, 80 times 15, so this blank needs to be 80. And then we said n was equal to 240. All right, question 2. 2 years later, researchers tagged 45 deer. They later captured 20 and found that 3 were tagged. Estimate the number of deer in the woods then. So we're going to completely erase our original problem because it doesn't matter anymore. They're just working with deer in the same woods, but none of the information from our previous problem plays into it. So 2 years later, researchers tagged 45 deer. So they tagged 45 deer, and we still want to know what the population is. So tagged over total, but we don't know the total. That's what we're solving for. Set equal to, they later captured 20 deer and found that 3 were tagged. So how many were tagged? 3. Out of how many that they captured? 20. So we'll do our cross products again. 20 times 40, 5. And we're going to set that equal to 3 times x, which is 3x. 45 times 20 is equal to 900. 900 is equal to 3x. Divide 3 to get x by itself. 90 divided by 3 is 300. 300 is equal to x. So now we can say the population of deer has risen from 240 to 300. We'll fill in our blanks. 45 deer. 3 were captured. 45 times 20. There we go. So here there are about 240 deer, and a few years later there are about 300 deer. Moving on to question number 3. Use proportions to estimate the number of each animal population. In another project, researchers caught and tagged 85 sea lions in the bay. So for number 3, researchers caught and tagged 85 sea lions in a bay. Later, they caught and released 50. Of the ones they later caught, 9 had tags. So later on, 9 had tags out of the 50 that they caught and released. What was the population in the bay? So again, our total population is what we're solving for. So we're going to do our cross products. 9 times x is equal to 85 times 50. 85 times 50. We'll then multiply 85 times 50 and then divide it by 9. 85 times 50 is 4,250, set equal to 9x. Divide out your 9 on both sides, 9 cancels. X is now equal to about 472. So there are about 472 sea lions in the bay. It's okay if you get decimals on these. You just want to round it up to the closest whole number. Number 4. Number 4 says, other researchers caught and tagged 5 spotted owls. Later, they caught 7 owls. Of those, 4 were tagged. Estimate the spotted owls in the forest. So, this is smaller numbers. Doesn't matter, though. Other researchers caught and tagged 5 spotted owls. Out of how many? We don't know. That's what we're solving for. Later, they caught 7 owls. So, total from their sample is they caught 7, and 4 were tagged. So again, cross products. Boom and boom. 5 times 7 is 35. Set that equal to 4 times x. Divide 4 onto both sides. Your 4's canceled out. 35 divided by 4 is equal to about 9. It's going to be a decimal. It's going to be 8.75. But since we're talking about animals, we're just going to round it up to the closest whole number, and we're going to say that there are about 9 spotted owls in the forest. And you can put that squiggly line above an equal sign to say that it's an approximation, or you can just put the squiggle line. That squiggle line says it's not exactly 9, but it's about 9. Number 5. An ecology class helped researchers determine the rabbit population in a nature preserve. One weekend, the students captured, tagged, and set free, so again, they're just changing the wording, but nothing is changing, 32 rabbits. So for number 5, even though it's a bit longer, they're still doing the exact same thing. They caught and tagged 32 rabbits. A month later, they captured 27 rabbits, including 6 with tags, to determine the number of rabbits in the nature preserve. So nothing has changed. They originally caught 32, but we don't know how many there were originally or total in the nature preserve. 2 months later, they come back and they catch a total of 27 rabbits, 16 of which were tagged. So we'll do our cross products again to be able to solve for x. 32 times 27 set equal to 16 times x. 32 times 27 is equal to 864, set equal to 16x. We're going to divide to get x by itself, so dividing out 16 on both sides. 864 divided by 16 is equal to 54. So 54 is equal to x. Or there are 54 rabbits in this particular wilderness or nature preserve. Last one, number 6. Another ecology class helped researchers determine the pigeon population in a city park. One day the students captured, banded, and released 200 pigeons. Again, this is the exact same problem, but instead of using the word tagged, they're using the word banded, meaning they put a band around the pigeon's leg or his little foot. That way they could recognize it again. And one day, they captured 200 pigeons. 2 weeks later, of the 24 pigeons they captured, 3 had bands. Estimate the pigeon population in the park. So, okay. How many did they originally tag? They originally tagged 200 pigeons. What's the total in the city park? We don't know. So, X. How many did they capture the next time? So, 2 weeks later. Of the 24 pigeons they captured, how many were tagged? 3 were tagged. Doing our cross products, we're going to have 3x is equal to 200 times 24. 200 times 24 is equal to 4,800, so 4,800. And that's still set equal to 3x. Divide to get 3 by itself. X is equal to 1,600. So we imagine there is about 1,600 pigeons in this particular city. All right, guys, you can now flip it over and do your homework. This one you'll do independently, and then we'll come back together on Zoom like we normally have to answer any questions or go through any problem points. Have a great afternoon.